Today we know that the beautiful, complex interactions within the brain can be upset by the tiniest chemical changes. Changes caused by emotions, environmental pressures, and stress. These minuscule changes can lead to significant shifts of behavior. But how feelings and emotions work and how exactly behavior is affected by chemical changes is still largely unknown.
Anxiety and stress are the buffer between an event in the world I must interpret and the way I'm going to respond to it.
In all probability, what stressful stimuli do is they don't produce any qualitatively different responses in the brain. What they do is they change the quantity and balance of the ongoing responses that are occurring. Stress is not some physical event which occurs to the animal or to the human. It is, in fact, that is a relatively minor part of the stress event. It sets the stage for the stress response. But the stress response is going to be critically determined by the nature of the environment in which that physical stressful stimulus is embedded and what the organism can or cannot do in response to that stressful stimulus.
In the animal kingdom, stress reactions are essential for survival. Approaching danger triggers the so-called fight or flight reaction, making new energies available for the big getaway. Under stress, a neurotransmitter is released by the hypothalamus, which causes the pituitary gland, the adrenal glands, and the locus coeruleus to release chemicals which keep the organism in a constant state of excitation. An air traffic controller comes to work at the Montreal Air Traffic Control Center. His name is Claude Bizarro. Airports depend on controllers like Bizarro. Air traffic controllers are subjected to high levels of stress on the job. At the start of every shift, Claude Bizarro has to read and acknowledge the day's memos. Bizarro, 40, is a married man with 2 children, and he's a loner. Already, the inevitable routine has set up a conflict between his feelings of independence and the knowledge that he'll be spending several of the next hours, an hour on, an hour off, earning his daily bread in a large, windowless cavern.
Yes, sir.
Claude Bizarro spends his workday surrounded by high technology, guiding unseen pilots to and from Montreal's Dorval Airport. Working in both French and English only adds to the stress. Claude Belval, 40, with 2 children and a third due any day, is a friend and colleague of Bizarro. Belval makes several pilgrimages a day to purchase packets of his favorite stress resistor from the machine in the cafeteria. But even during the most boring moments, there is always the fear of losing track of one of the airplanes stacked up on the board. And watching over them all is the new young boss, another inescapable source of stress. You can't fight your boss, nor can you flee your job. No one can predict when an airplane will have a problem.
29.5. He reported level at 24 in my frequency.
And the messages keep coming. Phone messages, boss messages, plane messages.
Second 75, Montreal. Would you confirm that you're level 240? He says he's level 24 Toronto. He's coming on 3563. Roger, 70. Second 75. Call to the Toronto Center now. Frequency is 356.3. And go ahead, you're passing radial from Val-d'Or TACAN, please.
Unrelenting low-level stress keeps the messages from the limbic system flowing to the frontal cortex. The physiological reactions to stress are kept constantly at a low boil. In the world of the air traffic controller, the constant stress means that the locus coeruleus is frequently active, releasing the neurotransmitter norepinephrine in the brain. fight or flight signals move ceaselessly from cell to cell. As more messages cross the synapses, the brain is activated again and again, keeping the organism revved up for fight or flight.
Well, I get stomach problems, yes I do. Maybe not ulcers, but I get very often gastritis, and I'm sick. My stomach is sick.
There certainly are the physiological responses which would lead to ulcers, heart disease, and cancer.
One gets to a place under that kind of severe, prolonged stress that your normal regulatory mechanisms are unable to cope with the demands that you're putting on them.
If stress is prolonged, if the brain has no chance to renew itself, the initial adaptation of the organism can be followed by exhaustion, disease, and even death.
The occurrence of that physical aggravating stimulus simply sets the stage for the stress response. That the stress response is then going to be determined by the environment in which it is embedded and what the organism can or cannot do about it.
You're unreadable. Try it again. I'm sorry, I just can't make you out. You're unreadable.
You always know that there's people on board. That's why until the last second you're trying to do anything to separate the airplanes.
No, 3594, I'm not getting your ident feature. Try it again.
594. Hein? Charles?
Ouais.
Tu vas prendre ton radar, là, ton Parrot, là, il est désagréable, puis il va le fermer complètement.
Ah bon, c'est gentil. 594, your radar contact. Ben, j'ai-tu le choix? Combien de temps qu'il commence à travailler dessus?
Ready to be out for 2 hours.
I'm sorry, 537, I can't make you out. Try it again, please.
Is the spacing for 537?
Spacing, you're spaced according to standard of the IFR.
Well, we just want to know if we're getting close to somebody.
First air is on the, just landed now into the wing. As soon as you're well clear of traffic in Val-d'Or, we'll be able to give you lower in the wing.
The unceasing alert signals from the limbic system eventually overwhelm the frontal cortex. The ability of the locus ceruleus and the rest of the stress network to cope is exhausted. The balance between the limbic system and the cortex goes to pieces, leading to erratic behavior. Now, finally, the radar comes back on. All the airplanes are still in the air.
The ability of the cortex to communicate with the limbic system and, in fact, with the rest of the brain in an ordered manner depends critically on inhibition. Otherwise, you get random messages firing off at once.
It was getting out of hand. The radar failed on me, and I had a few aircraft that I was using radar separation, and all of a sudden I couldn't use it anymore because no more radar.
Bell survived the intense stress of his radar crisis, largely thanks to a neurotransmitter called GABA. GABA inhibits cells from firing, diminishing the excitatory messages reaching the frontal cortex.
What GABA seems to be able to do is to lower the excitability level of the cell that's about to receive incoming information.
But if the stress is prolonged, GABA's ability to block the passage of messages decreases. Soon, the usual process by which signals are rated for priority breaks down, and the frontal cortex is literally bombarded.
Most of the time when I'm tired, it's after a painful session. I feel tired, physically tired. Must be mentally too.
Many stress victims are helped by the benzodiazepine family of drugs, which includes Valium.
Valium is a member of a class of drugs that seems to work by improving the effectiveness of GABA transmission.
Valium addiction can occur, but the drug helps most people suffering from stress by enhancing GABA's inhibiting action. It prevents too many excitatory messages from reaching the frontal cortex. And where are the receptor sites most affected by Valium? Researchers in Copenhagen suspected they were concentrated in the parts of the brain most involved in our emotions. Their research helped establish that benzodiazepine receptor sites are concentrated in the limbic system. Receptors are seen as white specks.
If the major lesson of 20th century biology is anything, it is that most neural tissue is involved in inhibition. In a sense, if you take away most of our brain, our behavior becomes disordered, not because we are turned off, but because everything is more or less turned on at once.